Hello, this is a lecture about database transactions. A transaction normally involves updating a database using insert, update or delete by using SQL instructions. It normally involves exchanging data between the database and an external medium, like for instance a hard drive. During the transaction, the database may be in an inconsistent state, but when the transaction has finished, it must have returned to a consistent state, and changes made to the database through the transactions must be permanently written to, for instance, a disk. Here is a classical transaction example. We have two accounts and we want to transfer $1,000 from one of the accounts to the other account. So we use the SQL update instruction, and we reduce the balance of the first account with $1,000, and then we run a new update instruction to increase the other account with $1,000. Then we have transferred an amount of $1,000. But what if the first instruction is run, but then the system fails for some reason and the other one is not run? Then we have withdrawn $1,000 from this account, but we have not inserted them into the other account. We can say that they have somehow vanished, and that's not acceptable. That's why we as programmer have to define what the transaction is, because we cannot accept that only this first one is run or only the second one. We have to run both to be sure that we bring the system from one consistent state to another consistent state. To do that, we would define both these instructions as one transaction, and we have to have a way to handle a situation where something goes wrong. We can consider a transaction as a logical operation, and we can have, for instance, one SQL query that affects only one row, but we can also have one SQL query that affects many rows. For instance, if we write a delete from and a table name, we will delete all the rows from that table. The transaction may also consist of several SQL queries, like we saw on the previous slide, where we had two update statements. To define a transaction, we use a begin transaction instruction and a commit instruction, and between those we will insert all the statements that are to be run to fulfill this transaction. If one of these fails, the system will not be in a consistent state, and then we have to bring the system to a consistent state. The programmer must define the transaction by specifying where it starts and where it ends. And to be able to secure transactions and bring it to a consistent state if something goes wrong, a log is created by the database management system. And the log is written to disk before the data is permanently stored. And then it can be used to either undo operations or redo operations. By reversing the operations, it will bring the system back to where it was before the transactions started. And by redoing it, it uses the log to run all the instructions that need to be run to bring the system to the new consistent state where it was meant to be. To do this, the log must keep enough information to be able to undo or redo the performed or planned operations. And that is the DBM's responsibility. So as programmers, we only have to specify where the transaction begins and where it ends. Here is an example of a transaction log where we are transferring $10 from one account to another. You see, this is like other tables with columns and rows, and we have 4 rows. And in the first row, it is specified that this is the beginning of a transaction, and the last row is a commitment. That means that the transaction has ended. And in the second row, this balance of one of the accounts is reduced by $10. And on the next line, the other account is increased by $10. So by using this transaction log, the database management system is able to either redo or undo a transaction. Some typical database failure is when we have, for instance, a power loss, which leads to a memory failure. Then the transaction log can be used to roll back the transaction or redo it, which means fulfill it. But if you have a disk crash, then you need a backup copy and need some other ways of restoring the database. But that is not something we look into in this lecture. If a transaction succeeds, then we have a commit, and if it doesn't succeed, we normally have what we call a rollback. We will now have a look at an example where we use a C# program to connect to a database and do some transactions. We have a database with two tables, like I've shown down here. One with where the teams are specified with a team ID and a team name, and one with the team members to be registered. And one team member belongs to one team, exactly one team, and one team consists of many team members. And here I have registered the 4 teams, as you see here, team 1, 2, 3, 4. And if I go to the other table, we can see that I have registered 3 ducks and 3 pigs. And all the ducks belong to team 1, and all the pigs belong to team 2. First, we will look at an example without transaction handling. I will use a simple C# form with 1 button and 2 text boxes. In these text boxes, I want to see how many members there are in team 1 and team 2. I have defined in app-config a connection string so that we can easily connect to the database. We can see it here within these connection strings tags, and I can then use conproject database in my C# code. So I go to form1cs, and here I have this conproject defined, and here I have the string we saw in app-config. I've also declared variables, num members team 1 and team 2, to be used to show how many members these two groups have in 2 text boxes. I initialize them to the value 3 in form1's constructor. When somebody clicks the button btn move, then I want one of the pigs to switch team with one of the ducks. So I will create a click event handler for this button. I need an SQL connection class variable and an SQL command class variable. I declare them and initiate them as null. Then I define 2 string variables, SQL query 1 and SQL query 2. And the first one is going to move member ID 3, which is one of the pigs, to team ID 2. The pigs are in team ID 1 originally. And team member 4, which is one of the ducks, is going to be moved to team ID 1, because the ducks are in team 2 originally. So these 2 queries are to be run, and we can see that if only one of them is run, then the database will not be in a consistent state, because then we have 4 members in one of the teams and only 2 in the other one. And we wanted to have the same members as before. We only wanted the 2 members to switch teams. Since we're now going to connect to a database and something may go wrong, then I use a try-catch structure to introduce exception handling. That means that if something goes wrong within this try block, then it will jump to the catch block and handle the exception that has occurred. I also use a finally block, which will be run whether the try block works well or not. And I use this to clear resources, like in this case, close the database. But I only want to close the database if it is open. So first I do this if check to see if this condition is fulfilled, because then the database is open and I want to close it. Because it could be the reason why the try statement failed, that this con open didn't succeed in opening the database. In the try block, I start by defining the connection and open the database, and here I also defined which query to be run and on which connection. Then I execute the query by using the command execute non-query. And down here I also reduce members of team 2 by 1, and I increase the members of team 2 by 1, which is to be done after this execution. This is done since I now have transferred one of the pigs to one of the ducks, so that team 1 is reduced by 1 and team 2 is increased by 1. So now there are 2 members of team 1 and 4 members of team 2. And the next thing to do is to run the next query, SQL query 2. That will transfer one of the ducks in team 2 to team 1. So we run this query, and then I have to increase team 1 by 1 because now the duck one of the ducks are transferred to team 1, and then I have to reduce the members of team 2 by 1 because now one of the ducks has left the team. Then I close the connection. So we can try to run this by clicking the F5 button. I start the program, and by clicking on this button, the transaction will be run, and hopefully we will not get any errors. So I click this button, no errors, and I see that there are still 3 members in both teams. I go to SQL Server, where I have my rows listed. That shows all the team members, and I see that I have 3 ducks in team 1 and 3 pigs in team 2. That's because I haven't updated them yet. So if I now click on the F5 button to refresh or run this select top 1000 once more, hopefully this transaction has worked well. I try, and I see that I now have 2 ducks and 1 pig in team 1, and I have 2 pigs and 1 duck in team 2. That means that both update commands are run, and the database are brought to a new consistent state. I have some queries here that will bring the database back to its original state. So I run these 2 statements by clicking execute. 2 rows affected, and if I now go back here and click the F5 button once more to run this select top 1000 rows instruction, then I can see that the database is now back to its original state. The next thing we will do is to let the transaction fail. We will do that by letting the first update instruction work well, while we let the other update instruction fail. And I can do that by setting the team ID to 5, because I have only registered 4 teams, so that means that we will have a reference integrity error. This foreign key team ID will try to reference a primary key that does not exist in the table named team. Then I know that this will fail. I click the F5 button to run the program. I click the button, and I see the expected message box. The update statement conflicted with the foreign key constraint. We see that we have 3 members in both, but this is updated after this one, so I click the OK button, and now I see that the first team variable is decreased by 1, and the second one is increased by 1. The reason why is that this first one is run without errors, so that members team variable is decreased by 1, like we see here, and team 2 variable is increased. But the next one has failed, so this execute non-query instruction has not been fulfilled, and these 2 statements are not executed. So the result has been that the database is in an inconsistent state. The data in it is not correct because we have only been able to run half of the transaction. We will now run the same program, but with the transaction handling. We will remove these comments to activate the instructions. So the first thing I do is to have this transaction variable of data type SQL transaction, which is a class, and I initiate it to null. Then I go down to my SQL queries. I will run the same 2 queries. The first one will succeed because this one moves member number 3 to team ID 2, which is okay. But the second one will fail because here I try to move member ID 4 to team ID 5, and we don't have any team ID 5, so that will be a reference integrity error. We try to reference the foreign key to a primary key that does not exist. And in the try block we define our transaction. It will start here, so I set that con, which is our connection, dot begin transaction is assigned to the transaction variable. And we also have to associate the command variable with the transaction, or else we get an error. So I remove this one. Command.transaction is assigned transaction. And the same thing I will have to do when we try to run the second SQL query. So also down here we have to associate the command variable with the transaction. And here, as I said, the transaction begins, and then we will have to define where it ends. And that is when all these instructions are run. So I remove transaction commit down here. So if anything goes wrong in this try block, which is defined as our transaction, it will jump to the catch block where we run a message box. And here I have inserted the text transaction was rolled back, and also written the message from exception error. And another important thing is that if this goes wrong, I have to call the rollback method, because then I want things to be rolled back to its original state, so that the database is in the same consistent state as it was before the transaction was tried. I run it by clicking the F5 button. I click the button here, and the event handler is run. Transaction was rolled back, so that means that it failed, which we expected. I click OK. And the strange thing now is I see that these two variables are changed, and we can see why. Since the first part of the transaction went well, I know that these two also were run, and that's why we have 2 and 4 in the text boxes. And since the second part failed, I will not have any results from these two, because the program has continued in the catch block, so they are never run. We jump to the catch block, and the transaction is rolled back, but these variables, the values that are changed in these, they are not rolled back. It is only the database transactions, the operations towards the tables, that are rolled back. If I want this to be correct, these two I have to run in my catch block. Then the numbers in the text boxes will be updated correctly. But if I have a look in SQL Server, we had 3 ducks and 3 pigs here, and if I click on the F5 button, I see that I still have 3 ducks and 3 pigs, so I have 3 members in team 1 and 3 members in team 2, so the database is rolled back correctly. I can try to run it once more with these variables in the catch block. I click the F5 button, click the button here, OK, and now I see that the numbers in the text box are corrected because the transaction was rolled back, and we will still have 3 members in each of the groups.